Hi, I'm Alessio Scalisi from Agriculture Victoria, and I want to give you a quick update on the activities of the Narrow Orchard Systems for Future Climates project that we carried out at the Tatura Smart Farm in the last 12 months. So we have two main sites at Tatura, the main experimental block with 5 crops, pears, apples, plums, nectarines and cherries. You can see the cultivars and rootstocks combinations in the top table. And the tree spacing and row spacing is standard 2 by 2. And then we've got different leader spacing for each crop with 33 centimeters for the pears, 25 centimeters for apples and plums, 50 centimeters for the nectarines, and 20 centimeters for the cherry, which of course leads to a different number of liters per hectares, as you can see in this slide. The second site we have at Tatura is a demonstration block with 11 rows, 10 of which are pink even M9 with double cordons and 2 by 2 meter spacing and a 2 meter height. Then we have an extra row of big bucks on M9 with a single cordon and 1 meter spacing between trees. We are running 2 little demonstrations in this block. One is on leader training with plastic clips, jute twine plus plastic clips, and then bamboo stakes plus metal clips. And then we are running a second demonstration using PRG and cytolin to enhance fast establishment of tree architecture. In terms of preliminary results, we are seeing that in apple, CG202 had the largest leader growth. In cherry, the Geisela 12 was the slowest at developing its leaders. In nectarines, rootpack 20 had generally shorter shoots, but not significant differences. And in plums, we haven't seen really clear patterns. And again, in terms of trunk cross-sectional area, in apple, CG202 had the largest trunks, whereas in cherry, the Geisela 12 had the smaller trunks than other rootstocks. In nectarines, there was a gradient from rootpack 20 to rootpack 40 to Wharton, and in plums, rootpack R developed the smallest trunks. And regarding pruning dry weights, in apple, again, the largest pruning mass was cut off CG202 trees, whereas in cherry, nectarine, and plum, pruning weights were similar in different rootstocks. The only crops that were able to flower this year were apple and nectarine, and you can see that G41 and M9 had a tendency to produce more flowers per tree compared to CG202. Whereas in nectarines, we have seen a tendency for rootpack 40 to produce more flowers per tree, which is in line with findings from previous research where we've seen rootpack 40 doing better compared to traditional rootstocks in terms of crop load and return bloom. We have also successfully used Green Atlas cartography to scan the Narrow Orchard Systems experimental site, and this is possible because we developed some new narrow scanning models algorithms with Green Atlas. You can see on the left the pears have a smaller leaf area, and that's due to the establishment being a bit late compared to the other crops due to initial problems we had with the nursery material. And then there was a bit of we estimated the leaf area, and you can see the effects of the different rootstocks are similar to what we have seen previously in the previous slides. And particularly in cherries, Green Atlas detected a significant difference in with Geisela 12 having a much smaller leaf area than Greensk 5 and Stallion. Our results on support structures for our upright leaders show that plastic clips are a bit behind compared to jute twine and bamboo stakes in establishing the leader height we wanted to achieve, which is 2 meters in this case, as you can see in the figures here. In terms of cost, the clips alone are much cheaper than the other two options in terms per hectare. Now, we are also using a simple Excel tool to calculate the number of fruit per leader based on the assumption that we had an ideal fruit weight in mind and a target yield per hectare. For example, if we had an ideal fruit weight of 225 grams for an apple and we wanted to achieve 130 tons per hectare, then we would need to put around 31 pieces of fruit per liter in our system. We're using several technologies at Tatura, and some examples are in the slides. For example, the scissor lift on the left, we use it to operate the netting and the rain covers. Then we have just procured a Kisui Adam autonomous robot with a mower underneath. And then we are procuring a little tow behind weed sprayer that we can attach to our burrow. And then we procured a new narrow vehicle to put cartographer on, so that we can drive up and down the narrow rows of our blocks. Then we have a PhD student, Harry Singh, fully dedicated to this project as a collaboration between Agriculture Victoria and the University of Queensland. And Harry is using LiDAR, 2 different types of LiDAR, to reconstruct canopy shapes and tree architecture to the finest detail. He's also working in collaboration with the Bioeconomy Science Institute in New Zealand. This slide just summarizes Agriculture Victoria's outputs in the last 12 months since our last PRG meeting. Thank you for listening to me, and let me know if you have any questions.